Hi student, how are you? Okay, in this video we are going to study the Newton law of gravity. Like Newton have different laws, Newton first law of motion, Newton second law, Newton third law of motion. But in this law we are going to study the law of gravity or Newton's law of gravity. Okay, let's see on the next page what is the Newton law of gravity. Or let's see here. So here in the definition they ask that, okay, let's see the definition. Newton law of universal gravitation state that the gravitation force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. Let's see what does it mean. Newton said that if when there are two masses, like this is mass 1, this is mass 2, Newton said that these two masses apply the force on each other and they will attract each other. So Newton said that let's suppose this mass apply the 5 Newton force, so this mass will also apply the 5 Newton force, mean the product of their masses. The second thing, like if we increase the mass, like this is 10 kg and this one is also 10 kg, so the force of attraction between the masses is also increased. The second thing, when the force of attraction is decreased, like if we increase the distance between these two masses, so like if we close together these two masses, so the force of attraction, Newton say the force of attraction these two masses will also be increased, but if we increase the distance, the force of attraction will also be decreased. So if we decrease the distance, so the force of attraction increase. If we increase the distance, so the force of attraction will be decrease. So let's see how he discovered this formula. F is equal to gm1 m2 divided by r square, like this is the Newton law of universal gravitational formula. Let's see how. Newton say F is directly proportional to the product of their masses, like when the object, if we increase the masses, so the force of attraction is also be increases. The second part, Newton say that if we increase the distance between the masses, square of the distance between the masses, so the force of attraction will also be increased. So it is inversely proportional to the distance but directly proportional to the product of the masses. But if we combine these two, like this is 1 and this is number 2, if we combine these two, so this will become like m2 divided by r square. This is inversely proportional and this is directly proportional. What is in the definition? Newton law of universal gravitation state that the force between any two masses is directly, this will show the directly proportional to the product of their masses and inversely proportional to the square, and this will show the inversely proportion after combining 1 and 2. So now it will become like if is directly inversely proportional to m1 and m2 divided by r square. This is not the proper equation. So now if I want to cancel the proportionality or finish the proportionality, so we can put the equal sign and also the Newton or universal law of gravitational constant, which is equal to g m1 m2 and divided by r square. This g will show the Newton law of universal gravitational constant, or simple we can say gravitational constant, whose value is equal to 6.673 10 raised to the power 11 Newton meter square per kilogram square. This is the value of the g, like simple, this is the universal gravitational constant value. So now the formula of the Newton law of universal gravitation is g m1 m2 divided by r square. Okay, let's see. We are going to solve some example of this law. Let's see the example. The distance between a 40 kg person and a 30 kg person is 2 meter. Like there are two person. The first person is 40 kilogram. The second person is 30 kilogram. And the distance between them is 2 meter. Okay, what is the magnitude of the gravitational constant exert on each other? The universal gravitational, the g value is already given, which is constant 6.67. Let's see, write the value is m1 is equal to 40 kg, m2 is equal to 30 kg. G value is constant, which is equal to 6.67, 10 raised to the power minus 11 Newton meter square per kilogram square. This is already, and the force of attraction is unknown. So putting the value G m1 m2 divided by r square. So if we put the value, so just I put the value, not the unit. So after this all thing is cancelled with each other, like kilogram square will be equal to kilogram square. So just I use the values. So this is equal to 6.67 multiplied by the first person mass one is 40 multiplied by the second one is 30, and the distance between them is 2 meter, which is also given 2 meter whole square. So now if we multiplied the value, so now this is 6.67, this is equal to 10 raised to the power minus 11, 40 multiplied by 30, which is equal to 1200 divided by 4 meter or force. Now if we divide this, so this will become 6.67, 10 raised to the power minus 11 multiplied by, if we divide 1200 by 4, so this is equal to 300. So now multiplied these two value, 300 multiplied by 6.67. So the last answer is 2 multiplied by 10 raised to the power minus 8 Newton. So this is the force of attraction between the two person which have a mass 40 kilogram and 30 kilogram, and their distance is 2 meter. Okay, on the next page, let's see. This is your homework. Try to solve this question. The distance between the earth and moon, like earth and moon, whose radius or distance is 3.84 10 raised to the power 8 meter. So what is the magnitude of the gravitational force? You will find the force. So you know the G value. Now you will find the earth mass and moon mass on the internet, throw on the internet, and then this will be m1, this will be m2, and just multiply the value and find the force or Newton law of universal gravitational force. So this is the first question. The second one, the distance between two planets, one having a mass m and the other of mass m, like the one mass is denoted by m, the other one is small m, and the distance between the two planets is d. How does the gravitational force change? So if the distance between the planet is double, so what will happen between the force? What will happen on the force if their masses are halved? Half mean if we decrease the masses, the third one, if the mass m is half, like the first one is halved and the distance between is double, so what will happen? This is the conceptual question. So try to solve the question carefully. So, and this is your homework. Okay, thank you so much. Let's try to solve the question. If you have any problem in the question, so you can ask in your comment. Okay, thank you so much.